Hi, hello everyone. So last time we left off with this simple, well, basically just red screen for now. And in this video, we're probably going to try to learn how to get some data to the GPU and then create, well, basic triangle. And triangle here is just sort of a hello world of WebGL, OpenGL, or any other rendering API. And for that, I'm probably going to spend just a couple of minutes explaining the pipeline. And basically the pipeline, the GPU pipeline looks something like this. So what does this mean? That means that, for example, first part is we have this kind of, right? We're looking at here. We have just data as vertices, and in code uh, that's nothing spectacular. It just looks like, well, basically, for example, sorry, we don't need this. Maybe I can move it. So the data that we get to GPU, this is complete example, might look just something like this, right? Or this, and these are basically screen coordinates at this point, but or rather they're vertex points. And in WebGL, as you remember, the screen goes from -1 to 1. So, for example, this would be minus, let's see, this would be minus 0.5, minus 0.5. This is in X, it is 0.5, and in Y, it's minus 0.5, and here in X, it's minus. So, for example, minus 0.5. Sorry, and in Y this is, yeah, this is 0.5. Anyway, you can add 0 here if you wanna. Anyway, that's how it works, right? So here -1, 1, 1, -1. Those are screen coordinates. Anyway, you will have all kinds of data, but usually in WebGL sorry, in graphics, you're going to multiply by some matrix that maps to this point. But anyway, we're going to get to that later. So also, what's important now is the second part of pipeline. That's the vertex shader. And what does the vertex shader do? Right, we have now defined where the stuff will be, and in vertex shader, well, basically this is just data, right? The vertices, and we get them to vertex shader, and then the vertex shader is actually responsible for saying where they will be on screen. And the vertex shader is just code. See here, right? This is the vertex shader. It's just basically shader code, which runs for each of the vertexes defined. So it runs once for this one, for this guy, and for this vertex here. And then it goes to primitive assembly. And what does the primitive assembly do? So we might have this 3 points right here, and we might want to render them just as points. Then we get this, right? And but also maybe we want to render them as lines. We can do that. In WebGL there is a way to say draw lines, and then it gets, sorry for the lines, these should be lines, but anyway. So yeah, and so it draws your vertices as lines. And the third primitive is triangle, right? Then it fills the triangle, and those are basically primitives in WebGL. So the primitive is kind of lowest. Uh, how should I say it? It's the lowest thing that you can draw, right? Your model is made of bunch of triangles, and then it's called a mesh. But if you take apart the model, it's just vertices basically. It's just data points, and those data points get connected to triangles. And so yeah, that's what primitive assembly does. It connects everything. Then we have rasterization. What rasterization does is it basically rasterizes our primitive. So it's kind of assigns pixels here, right? It's, the triangle needs to be made of a bunch of pixels, and then we have a pixel shader. And what pixel shader is same as vertex shader here. We have pixel shader, which will run for which will run for every pixel here, and it's also a shader code, so I can show it, which just determines the final color of a pixel. Give me a second here. I have a fragment shader here, and the color we get it from outside here, and this is our final color, so we just assign outside color, which is of factory, so RGB here, for example, G and B, and then that's our final color. And then the final step is just to present everything to frame buffer and draw everything on screen. So this is really simplified ORF pipeline. I'm going to link this article in YouTube description video. And with that said, we can start coding. This will all make sense as it will all make more sense as we go along. So okay, let's continue. So first I wanted to actually start with this part of the pipeline, vertex shader, and then pixel shader as well. So let's just start writing our shaders, and then I'm going to explain them a bit. So as I mentioned, shader, come on, shader is just a code, nothing more. So well, let's just write them. You can load them as string. Actually, we're just going to read the file, and then it's going to be a string in code. But yeah, I want to keep them separated as files for now. So let's say we shader. The name is not important. The extension is even not important as well, but GLS is kind of common. So we're going to say this. Why version? It's just well, historic reason kind of, or not sure, but WebGL 2 basically corresponds to OpenGL as 3.0. Therefore, that's why this version says 300. Yes, bit weird, but that's how it is. Then we can say precision, medium p float, that's fine. And then actually we're going to have some attributes that we're going to get in the shader. So let's say I think like layout second. So we use this kind of attributes just to say, well, it's sort of like address, right? And this will be position, and then we're going to have color. Actually, it's going to be vec3 a color, and A stands for attribute here. We're going to cover it in a second, and then we just have main function like this. This is fine. All right, let's just cover it. So I mentioned this precision medium P, higher precision, lower performance, but better precision. So medium P is good, probably good value here. It can be high P or low P. This location, actually we're going to get to that, but it's just the data that we pass from the CPU to the GPU. Once we load it, we need to somehow know how to read the data, and we're going to cover that because it needs to be described on the CPU. Here out word means that we're just going to pass it further down the pipeline in fragment shader, and then we're going to actually use this vcolor in fragment shader, and here we just pass it. And this is GL keyword, so you always specify position of that, and that this position is kind of position of this, let's say, pixel here, sorry, this vertex here. And then we just need a fragment shader as well, and that's easy. Let's just create a fragment shader. So just remember, fragment shader runs for each of the pixels in our geometry. And then why is color not working? This is, sorry, mistyped it. I'm using some Visual Studio extension for the coloring here, and actually not. So it was called vColor. So this is how we get a color, and we just need to output the final color, and that's going to be this main. So yeah, this is it, as I mentioned. So we're going to pass the color from the CPU to the GPU. We just pass it further down the pipeline, and then it's used in fragment shader with a keyword in. We said it's coming from the vertex shader, our output color. So you can have multiple outputs, but for now we're just going to use one, and we might cover how to use multiple outputs from the fragment shader, but just so that you know, it needs to have some output value, and that's this frag color, and this is the final color of our pixel. So each of the pixels here will be colored based on that, and actually just the vertex is colored, and then it's interpolated between the vertices. Anyway, so for example, this one on this corner is one vertex with green color, vertex with red, and this is with blue. Anyway, let's actually cover. This is just for reference. Anyway, let's just cover how do we actually load the shaders. All right, let's actually load those shaders. For that, we're going to need a program, WebGL program, and what the program is, as I already explained, it's just going to hold our shaders. But let's actually start with the program. So we're going to have maybe private, not the create shader, but actually create program, which is going to be a WebGL program, and it's going to take in maybe shader source, text shader source as a string, and then shader source. All right, we're going to create this function later or right now. So add all missing members. We're going to fill up this later, and here to create a program, so we need both shaders, and here it will be WebGL shader. So we're going to fill up the details, but to create a program we need a vertex shader and a fragment shader, and then we call create program. Then we need to attach those shaders to a program like this, and then we need to link the program, and then we can just check for the errors. If not success, then we can say no, I actually want to get the error, and it actually gets the error, but let's just not do that. Let's console error stuff, and I would probably do it more like this, using string interpolation. Program failed to link, and then we just delete the program and we can return. So let's actually now, since we need shaders, let's input shader, vertex shader source. We must say row here to actually import it as string, and then this is wrong. And then know what? Maybe actually let's do the shader here instead of source. WebGL. I think it's a bit cleaner. So we load shaders once and then we can use them. shader, and then perfect. Generate some documentation. Create WebGL. And returns WebGL program. Perfect. And now actually let's fill up the create shader. Be private. Here it's type, and here is shader source. So similar to how we create a program, we just have GL call create shader, and usually we pass here either vertex shader or fragment shader. You will see it in a second. Then we need to specify the source, and after the source we need to compile it. And similar to how we checked error when creating a program, a WebGL program, here, right? I mean, the workflow is kind of the same. Create program, then we attach shader, then we link the program, and then we check for the errors. And here we just create a shader, add source to it, compile it. You need to compile it, and then you can just check for the errors. Compile status, if not success. Perfect. And then return shader, and we can just maybe add documentation here. Type is either gl.vertex shader or gl fragment shader, shader source code, a string. All right. And let's actually try to compile it. So we need const vertex shader. See here, these are the types, and they're available from the GL object, right? Which we have here as WebGL rendering context, and then we just paste vertex shader and then paste the source, and the source is this as a string. And same is for fragment shader. We just specify fragment shader, and then we can finally create a program. But the program is global, and that should be it. And then we just need to say use program, and that's probably it. Let's just see if it compiles successfully, if we have any errors. Refresh. No errors. Perfect. So how would you check for errors? It's really simple. We can just break shader a bit. Let's say here vec 4. This will break it because we're assigning vec 3 to vec 4, and this should break it. And as you can see here, we're printing the error. Blah, 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 dimension mismatch. Cannot convert from median component 3 vector of float to out median component. Perfect. And then it also the linker fails. This is perfect, and it also says the well, exactly where the error code is, and that's on line 12. Line 12, it complains here because this assignment is wrong. And if I correct it, go back, there is no error. And that's how we load the shaders. Then let's see how to create well, basically now that we have a shader, we actually need to load the data to GPU, and for that we need to create what's called WebGL buffer. Oh, perfect. And so this is how you create it. You just use GL create buffer, and it can be of array buffer or element array buffer. We're going to cover element array buffer a bit later, but here you just say bind buffer. So now this buffer is in usage, and you can fill it with data. And then we also have this command buffer data. We specify the type once again, Data needs to be signed because in JavaScript arrays can be array of anything, right? And here we actually want to interpret it as a floating point, 32 because well 32 bytes or bits, 32 bits, and then static row. It can be dynamic row using static because we're not going to change this buffer at all, and then we just need to return it. Okay, and let's document it. Create a buffer to store data to the GPU. Data to store, and then we return WebGL buffer. Perfect. We now have buffer, and now let's define our data. This create buffer, and we just paste in the data. And what we used is, I believe, let's see. As you remember, the coordinates are going from -1 to 1, and this would be, well, let's go from this corner, then the right, and then this green one. Or actually better, red, green, blue. So red corner is minus 0.5, right? Because here is 0 and here is a negative x, minus 0.5, 5 and minus 0.5 for y, right? Because up is positive, here is negative, so this is middle of the screen. And then let's actually do that. So what did you say? Minus 0.5, minus 0.5, minus 0.5, 0.5, and then 0.5 and minus 0.5. Okay, and the next step is actually to describe the data. So I already have suggestion here, and what this does is actually it can get us this location, and then we can work with this location. But since we already specified it here, I don't need this one because I already know the location, so I can get rid of this, and then it will be this GL vertex attrib pointer. Let's see, we're using 0, 2. Okay, so just to explain the argument, 0 here corresponds to the location here. All right, that's sort of like an address. 2, because we're using vector 2 here, right? It's vector 2. Then GL float because we're using floating points. This is normalization parameter. We don't care about it. And this I will cover this later, but basically it's byte offset and the stride. Maybe better to cover it in one of the next videos. It will be too much, and then we just need to enable it, and we are enabling it for location 0. And then let's create our colors. And what did we say? Red, green, blue, right? So 0, 1, 0. Yep. And all right, we need to describe it. You might already figure this out. And the suggestion is actually really good. 1, because layout location here is 1. We're using vector 3 here, so the second argument is here, and it's also float. Vector is by default float in WebGL, and then we just need to enable it. All right, just to recap. So basically, we just have this command which will create our buffer, and the buffer is a memory that goes from the CPU to the GPU. We just bind it, we buffer the data, so we put the data into the buffer, and then we need to describe the data, and then how basically we describe how the GPU is going to read it, and yeah, that's it. All right, and then we just need to draw everything. And here in draw, this will be easy. Our buffers are already bound, our program is already bound, and we can just use GL draw arrays. This is our final example. And here it fails because why it fails? Why does it fail? Let's see. GL draw arrays, triangles. Let's just change the color to correspond to our final example. Ah, it's actually here. It's weird. It should have been here earlier as well. Let me just check something. What did we have here previously? Was that an issue? 100? Ah, maybe it just wasn't refreshed properly. But anyway, you see it here. And with that said, that's our final example. Just to explain something really quickly, since we're here, we covered everything. And now we can also draw points. There are 5 or 6 modes, but they essentially draw points, and you cannot see them because they're too small. But we can do this. GL point size, I believe. This, and we can maybe make it. You see? So now we're drawing it as points, and then we can also draw as lines. What was it? Lines. And there is one line because we're missing some data here. We need to define this twice because here it ends as well, and I believe we need to define this twice as well, and then the first argument here, and then let's see, and here. Aha, I haven't explained this. Well, basically we just describe here how many of our vertices we're going to draw, and something is wrong. Probably because I need to duplicate the colors as well. Let's see. No. Ah, no. Yeah, here it is. Perfect. Yeah, see, this is how you essentially draw, and that corresponds to this part of pipeline here, right? When we specify draw, we said how we basically say to WebGL how do you well, what do you draw? All right, it can be points, lines, or triangle. And with that said, that's it. So in the next video, I believe we're going to cover index buffers and probably texturing. So that's all for the next video, and then until next time.